All right, so now we're going to move on to assignment number 3. Two things we're doing in this assignment, assignment number 3. The first one is we're going to be graphing exponential functions. That includes both exponential growth and exponential decay. And we're going to translate them. So we're going to learn how to shift them so that the center is not always at the origin. And we're going to shift them in 4 different directions: up, down, right, and left. The other thing that we're going to talk about today is half-lives. So you have heard that maybe radiocarbon dating has a half-life of a certain amount of years. And so we're just going to take a look at an example of what a half-life function looks like, which is an exponential decay function, and talk about how to write those equations and how they apply to different situations. And so let's go ahead and get started with today's homework assignment. So we're going to start just simply by graphing y equals a times b to the x. We know that if there is an equation that is an exponential form, that's the form that it's going to be in. And so let's just make sure that we know what we're doing to graph those. If I have an equation that is y equals 3 times 2 to the x, things that we're going to need to remember, I suppose we should probably put down first, is that this a value right here is the beginning amount. So we can talk about investing $2,000 in an account. The beginning amount would be $2,000. We can talk about a car that's worth $3,400. The beginning amount would be $3,400. The b value is the growth factor. That tells you how it's growing if it's exponential growth. It also talks about how it's shrinking if it's exponential decay. So in this particular example, the 3 tells us where it starts. We could, if we wanted to, we can make an x and y chart here, and I won't do this for every situation that we're going to come up with, but let's say that x is just 0. If x is 0, we know that anything to the 0 power is 1. So when I plug 0 in for x, 2 to the 0 is just 1, and so 3 times 1 is just 3. So the first point is going to be right here at 0, 3. Then if I plug in a 1 for x, that means I'm going to take 3 and I'm going to multiply it times 2 once, which is going to give me 6. So I'm up here. So it's doubling. And when I plug in a 2, it's 2 squared. 3 times 4 is 12. So I'm going to take that 6 and I'm going to double it, and it's going to be up at 12. So you can see this is growing kind of rapidly. It starts at 3 and then 6 and then 12, and then it'll be up to 24 and then 48 and 96 and so on. So you can see how it grows really rapidly. If I plugged in a negative number like -1, we know that to make a negative exponent positive, we'd have to put it on the bottom. This would be the same thing as 3 times 1 over 2 to the first. And that's 3 times a half, which is 1.5, which is right here. And as we go back, we're just cutting this in half each time. Notice that it's not ever going to cross the x-axis. This x-axis is an asymptote. It's going to approach it, but it's never going to touch it. It's going to look something like this, and then just shoot way up. It's going to go forever to the left, forever to the right. The beginning amount is 3, and as we move from one point to the next, it just doubles, because that's what the growth factor is. Let's take a look at a different example. Let's take a look now at example number 2. You can tell by looking at this equation that it's not exponential growth, it's exponential decay, because the growth factor is less than 1. It does start at 8. I could make an x and y chart, and if x was 0, 0.5 to the 0 would be 1. 8 times 1 is 8. So this one's going to start at 8, which is right here. But as we go over to the right, and as we plug in like a 1 and a 2 and a 3, it's just like I'm multiplying it by 0.5. I'm cutting it in half every time. So the 8 is going to become a 4. 4 is going to become a 2. 2 is going to become a 1. 1 is going to become a half. A half is going to become a fourth, and so on. And again, we're going to have the same asymptote down here along the x-axis. It's going to start really high, and as it gets closer and closer to the x-axis, it's going to slow its rate of shrinking down, and it's going to look something like that. The big thing I want you to see here is that the beginning amount is 8. That's what this 8 tells us, and then the 0.5 tells us how it's growing, in this case, shrinking. Let's move on. Let's take a look at example number 3. And example number 3 starts out at 5. So I'm going to just put a point right here at 5. It is growing, but it's growing at 20%. because it's 20% more than 100%, which is just going to be 1. Well, if I took 5 times 1.2, I'd be at 6 here. Then if I keep multiplying, 6 times 1.2 is going to be 7 point something, and it's just going to become a little bit, the rate of the growth is going to be a little bit slower. And I could plug in all these values to find out what the exact values are, but it's going to be something along this line here. It's not going to grow quite as fast, but it is exponential. As we move to the left, it's going to approach the horizontal asymptote, which is along the x-axis, and it is going to grow faster and faster as we move to the right of the graph. All right, so let's take this idea of y equals a times b to the x power and talk about what it would look like if we extended it. We're going to continue with 4 more graphs here, except now we're going to be talking about, it's still a times b to the x, but we're going to have the x minus h and then plus the k. We're going to see what the h and the k do to the graph, as well as having both a positive and a negative a value. And so I'm going to start with number 4. Number 4 is kind of like what we did in number 1 too. We had 3 times 2 to the x. But what happens if we take that x and we subtract 3 up here first? And so I don't know if you remember when we were graphing this the first time, we had a point at 3, but we plugged in a 0 to get that 3. Well, now in order for this to be equal to 0, our x value is going to have to be 3. Because if I plug in 3, 3 minus 3 is 0, and then 2 to the 0 is 1, 3 times 1 is 3. So we're going to have a point right here at the point 3, 3, which is here. And then I can plug in other points, like let's say we plug in 4. 4 minus 3 is 1, which is 2 to the first, so 3 times 2 is 6. And so that may, let me make sure that point stays here. Then I'm going to have a point at the point 4, 6, which is up here. I don't want this one to go away. All right. What's here and here? All right. And then when I plug in 5, it's 5 minus 3 is 2. 2 squared is 4. So this is going to be at 12. So the point 5, 12 is going to be up here somewhere. And the exact same graph will happen as the first time. The only difference is that it's shifted, and it's shifted 3 units to the right. So this h right here is going to shift things right and left. And you might say it's opposite of what you would think. If it's x minus 3, it's going to go to the right 3 units. And if it's x plus 3, it's going to go to the left 3 units. And so this is like where our origin has shifted to, just 3 units to the right. The asymptote is still at the x-axis. Okay, so that's what the x minus h does. Let's take a look now and see if we can figure out, let me get back there, see if we can figure out what the k does to the graph. And so let's move on and take a look at number 4 here, or number 5. And so this is the same graph that we started with on the previous slide, where we started at 8 and we cut it in half each time when we move to the right. Except this time we're going to take all those values and subtract 6. And so for example, when I plug in 0 for x, normally I would have 5 to the 0, which is 1, and 8 times 1 is just 8. And we had 8 before, but now I'm going to take that 8 and subtract 6 from it, which puts it at 2. And so instead of starting at 8, it's going to start at 2. And everything is going to be shifted down 6 units, including our asymptote. So this is what the asymptote is going to be at. It's kind of like my origin shifted 6 units down, and I'm kind of starting at 1, 2, 3, 4, 5, 6, 7, 8 from my origin. And then I can just act as if this is my point 0, 0. And if I start at 8, the next point's going to be at 4. The next point's going to be at 2. The next point's going to be at 1. I don't know why they're going away, but they are. And so I'm going to have a graph that looks something like this. And again, it's going to approach the x-axis, but it's never going to cross the horizontal asymptote, which is at -6. So what does the k value do to the graph? The k value moves the graph up and down. Okay, up if it's positive, down if it's negative. And it just shifts things over. All right, so let's take a look at number 6. And as we continue here, number 6 is just like what we had in number 3 on the previous slide, except instead of starting at +5, it's going to start at -5. So I probably should clear everything off here. I'm just going to leave it here though. It's going to start at -5, which is right here. And what we're going to do then is when we start at -5, we're just going to multiply -5 by 1.2, which is going to be at -6 the next time when we go over to +1. And so when I do that, I have a point, my first point at 5, my second point, or -5, my second point at -6, and then it's going to be at negative a little bit more than 7, and the asymptote is still going to be along the x-axis. It's going to start off close to that asymptote, but then it's going to go through those 2 points and continue to grow, but instead of growing in a positive direction, it's growing in a negative direction. So this is an exponential growth problem because the growth factor is more than one, but it's actually growing more and more negative. And so it's just flipped over the x-axis, and it would look like the purple graph that's there. All right, so let's put all of these ideas together, see if we can graph number 7. And I don't know if it's going to be easiest to do that. Maybe I'll just erase all these things here so that we can get a better idea of what's going on here. If I start all over with all of these graphs and graph just number 7, then I'm going to have something that looks like this. I know because it's the +2, I know I'm going to have a horizontal asymptote at +2. I know that it's going to start at -16 from here, my new origin. So I'm going to go down 16, which means I'm really going to be at -14. There's where my graph is starting. And then the growth factor is, oh, I got to move to the left 4 units. So it's actually starting 4 units to the left. My origin is right here. Now I would go down 14 units from that, or 16 units from that, which would put me at -14. And I can't see those numbers. I'm going to guess that -14 is about right here. All right, so there's my first point. And then it's going to be cut in half each time. So I'm going to go from that point to my next point, which would be at, instead of -16, it would be at -8. And then -4. And then -2. And you can kind of tell it's going to do -1. And it's going to really approach that asymptote there, but it's not ever going to cross it. And it's going to look something like that. And I can identify those points if I wanted to graph this a little bit more precisely. So those are the graphs. I am going to move on. I have one more question here, but for the sake of time, I'm going to start this with a new video. So you'll need to go to the next video to talk about exponential decay. And once you start that video, we'll do this problem, the final problem, number 8, which is on half-lives.